Okay, so now we have another one, and here come the participants. Good. So now I can start the XOR. Okay. And here it is, the joy of XOR. All right. And that thing is trying to tell me that it's done processing something, which I don't care about right now. Okay, so we're going to do up to 4 bits of XOR. That's all we're going to do in this one. So if you have 1 bit of XOR, 0 XOR 0 is 0, 1 XOR 1 is 0, 0 and 1 XOR gives you 1. If the 2 bits are different, the answer is 1. If the 2 bits are the same, the answer is 0. That's all there is to it. In the book, they use this plus with a circle around it, which is the mathematical symbol. In Python, you use a caret, which I'm used to seeing used for exponentiation, but that's what you do. It's XOR. So we'll use Python to do it largely in this class. So here is how we XOR 1 bit in Python. Let me just do this one live. Python is your friend. Python. And let's zip it up. Okay, so I'm going to put it up here. Come on, I'm going to put it up there. I say, there we go. All right. So if I do 1 is 1. If I do 1 XOR 1, the answer is 0. If I do 0 XOR 1, it's 1. If I do 0 XOR 0, what's it going to be? 0. Okay. And if I do the last one, which is 1 XOR 0, what's that? 1. All right. That's all the bits, single bits. So now you can do more than 1 bit. You can do 2 bits. 0, 0, XOR 0, 0, 0. You just do the bits one by one. The left bit, 0, 0 is 0. The right bit, 0, 0 is 1. So 0, 0, XOR 0, 1 is 0, 1. Because these left 2 bits match. The first one is 0 in both cases, and the right 2 bits are different, so you get 1. 0, 1, XOR 1, 1 is 1, 0. Because these 2 bits are different, the 0 and the 1 giving you 1, and the second bit, 1 and 1, are the same. So it's just more bits. You just do the bits one by one. And you don't have to worry about carrying or anything like you do with addition and subtraction. You just process the bits one by one. And you can do that in Python, and it's worth knowing how it looks. If you want to write binary numbers in Python, you start them with 0b. So 0b, 0, 1 is 1. And 0b11 is 3. Hopefully that's reasonable. That's 1, 2, and a 1. So now you can do 2-bit XOR. So I can do 0b00 XOR 0b01. And the answer is 1. Now if I want the answer to come out in binary, I enclose it in bin to turn it into binary. And now I can do straight up binary input and get binary results. 0b1. So if I do this one, if I do 0, 1, XOR 0, 1, what's the answer? What's that?
1.
0, right? Both bits are 0. I'm XORing 2 numbers that are the same, I'm going to get 0. If I put a 0 here, what's the answer? Now it's going to be 1. If I put a 1 here, what do I get? 1, 1, right? Because both, your first bit is 1 and 0, next second bit is 1 and 0, so you get 1, 1. All right? It might. The thing that troubles me is I think it might be 11 you're XORing. That's that. I put the 0b in to make sure. Right. Right.
One or the other, but not both.
All right. So there's 4 bits. Let's try a few of them. So if I have 1, 1, 1, 1, and I XOR it with 0, 0, 0, let's say 4 zeros, what's the answer? 15. 1, 1, 1, 1. Right? Because each one of these 1s is different than each one of those zeros, so you keep the 1s. So if I do this one, what's the answer?
XOR, basically like it's like
0, 1, 1, 1, 7. Good, you got it. So how about that one?
0, 1, 1, 0.
0, 1, 1, 0, which is 6. Okay, is that clear? Well, if you got that, then I think you're ready for the glorious cahoots.
Oh, sure.
All right, that's the joy of XOR. And there should be an XOR Kahoot, and there it is. Okay. All right. There you go, 508, 501. That's a very good point. It's probably not all that random because I don't think people care that much. But that's why games typically use kind of sleazy random number generators, because it doesn't have to be too random for that purpose. And this is basically a game. But in cryptography, you have to have better random number generators. What's that? I don't think they can see the questions. All they can do is join the game. Not until I started. I think, but if they could, they'd have to guess my password to see a question, as far as I know. But I don't know about their server. Their server might have, you know, the stretch call they're building, everything else on it.
No. I mean, anybody, anywhere, can, if they have that pin.
That's right. That's the way it is. Yeah. I think I could restrict it to, I could have a password required or something, but I don't care. Yeah, because this is streamed for anybody in the world to watch it. In fact, I don't think anybody is watching it. It's not a student, but they certainly could. All right. Anyway, let's give it a shot. So, 6 of these. Glorious XOR. Okay, what's 1 XOR 1?
Come on.
All right, it's 0. Good. How about 0 XOR 1?
Come on.
All right, that's 1, of course. How about this? 1, 1 XOR 0, 1. The 0B in front means it's binary. All right, it's 1, 0. Good. All right, 1, 1, 1, 1. XOR 0, 1, 1, 1. All right, and that means 1, 0, 0, 0. But all the 3 1s on the right go away. All right. How about this one? 1101 XOR with 0. No, I generated it. Yeah. All right. That's right. It doesn't change. XORing with 0 does nothing. So it stays equal to 1101. All right. And there's one more. 1101 XOR 0110. All right, it's 1011 because 1101, 1101, the only place where the bits are the same is the second bit. So the second bit changes to 0 and all the rest are 1. All right, and I think that's it. Yep, all right. So it's W, tip, tip, and Equifax. Okay, so I think that's it. That's enough for one day. You've got more quizzes and such due next week. Let me just bring this stuff up.
It's always holidays on Monday.
They haven't not read. There was a holiday last Monday, but they didn't. So next week you should be up to your projects and quiz on chapter 3. All right, I'll stop the Zoom and go to the lab and help anybody that wants help there.